All right, so today what we're going to do is we're going to continue factoring like what you did on Friday, um, but we're going to talk about special properties or special types of quadratics that you can factor. Um, Understand today's lesson actually can be done using the exact same things that we did on Friday, like what two numbers multiply to C but add to B. But the thing is that your A value, your leading term, is not going to be 1 like what they were on Friday. So I just don't want you to get frustrated or freaked out. You will eventually learn a couple other ways to actually attack these problems where you don't have to do today's lesson, but I thought it was kind of cool that you can see and try to pick it up on your own. So today what I'd want you to do is I want you to first start by your notes up at the top. I want you to do this warm up. All right, I want you to do all of them. And once you're done, I want you to after pausing the video, I want you to press play and I want you to check your answers. Again, make sure that you factor out a GCF if you can, and then try to factor it into two binomials if it allows you to do so, meaning that it starts as a trinomial. So press pause, try those warm-up problems, and then press play when you're done. All right, so here are your answers. All right. Now notice 1, 2, you didn't have to factor out a GCF, it's just normal factoring into two binomials. But 3, you could start by factoring out a GCF. And one thing that gives that away, and this is going to be huge that you start picking this up, is that that leading term is not 1. Always try to factor out that leading term, that A term, if it's not 1. And that now then will make it easy, because this is now a nice little trinomial that you can say, hey, what two numbers multiply to negative 18 but add to 3? Well, when you list out your properties, you'll have 1, 18, 2, 9, 3, 6, and you're like, hey, 3 and 6 will give me 3 when I add or subtract, so bam, that's how you get 3 and 6 there. You can check the rest of these answers by pausing the video. 6 as well, factor out your GCF of 4, 8, factor out a GCF of 5, and then the rest of them you just factor originally. So, all right, now today again is just like an extra mini lesson, all right, that kind of helps you see certain special types of polynomials that you can use a little special property on. So first thing I want you to do is I want you to try to multiply the following. So pause the video and I want you to multiply 10, 11, and 12. All right, so multiplying these, you should have gotten, after you double distribute, you should have gotten x squared plus 3x minus 3x minus 9, which when you combine like terms, you get x squared and 3x minus 3x, those cancel out, so you get minus 9. And number 11, you should have gotten when you double distribute, you get x squared plus 5x minus 5x minus 25, which when you combine like terms, the 5 and the negative 5 cancel out, so you get x squared minus 25. And then lastly, in 2x plus 1 and 2x minus 1, when you distribute here, 2x times 2x is, not 2. Already made a mistake. Sorry. It's not 2, it's 4x squared, and then 2x times negative 1 is negative 2x. 1 times 2x is 2x, and 1 times negative 1 is negative 1. So when you combine like terms, 2x and negative 2x cancel out, so you get 4x squared minus 1. Now notice all your answers here, here, and here. When you double distribute, what happened? Now if you're like, I have no idea. Well, usually when we double distribute, we get a trinomial, 3 terms. How many terms do we get here? 1, 2, 1, 2, 1, 2. You get 2 terms. Now, why does this happen? Well, if you looked at the problems when they originally started, if you looked at how they were, x plus 3, x minus 3, x minus 5, x plus 5, 2x plus 1, 2x minus 1. Those binomials are almost the exact same thing. They just have a different sign in between the variable and the constant. So what we call this pattern that we're noticing here is called the difference of squares, right? It's called the difference of squares. Difference of squares. And what this means is that anytime you multiply two almost identical binomials together, but they have different signs, their product is just going to be a binomial. Really, it's just x squared minus whatever the two constants were multiplying together. Now, why would I have you do that? Well, the difference of squares comes in when you do problems number 13, 14, and 15, because if you look at those, all right, that's not what we factored on Friday. This is a binomial. On Friday, you did stuff that looked like this. You did stuff that looked like x squared plus 5x plus 6. And you factor that. You're like, hey, what two numbers multiply to 6 but add to 5? Oh, x plus 2, x plus 3. And you guys crushed that. So today, it's like, oh my gosh, well, what do we do here? Well, I'm going to show you. We're going to actually do what we just did with those double distributing. All right, we're going to do that, but we're going to go in reverse. All right, so what you should hopefully see and notice is that when you do this, x squared minus 9, notice because that middle term is gone, we're going to put this and make this into two binomials, but what's going to end up happening is it's because it's called the difference of squares. To get your answer, if you take the square root of your a term and the square root of your c term, because your x squared and your constant, if you take the square root of it, the square root of your a term is actually your first terms over here. So the square root of x squared is x. The square root of 9 is 3. So you go plus 3, minus 3. And that is your binomial using the difference of squares. So anytime you see a binomial, and a binomial where both of your terms in there, if you look here, like over here in the first problem, it was 1 and 9. 1 and 9 are what we call perfect squares. Notice all these numbers, 4, 25, and then over here in 15 is 1 and 1, and then 49 and 4. You're going to notice you can only use this when those numbers are what we call perfect squares. So you're going to notice that this can only work with those perfect squares. So let's look at this next one. All right. So let's look at this next one. All right. So to do this and use the difference of squares, I just basically take the square root of the first and the last term, your a term and your c term. And that's what I'm going to use in my binomial. All right. So I say, all right, if I did 4x squared, if I took the square root of that, that's going to be 2x and 2x, because the square root of 4 is 2, the square root of x squared is x. And if I were to take the square root of 25, I'd get 5 and 5. And then you have a positive and you have a negative. All right? So that is called the difference of squares. So now for the last ones, all right, for the last ones here, we're going to do the same thing. All right? Because your a term and your c term are both perfect squares, and it's a binomial here, we can use the difference of squares. So we take the square root of your a term, the square root of your c term, and you say, all right, here we go, ready? The square root of x squared is x. You get x and x. And the square root of 1 is plus 1 and a minus 1. Well, really it's 1, but you get a plus 1 and a minus 1 there. So pause the video and try this last one, number 16. Press play when you're done. All right, so now, hopefully you did this. You said, oh, hey, 49 and 4, those are perfect squares. I can do the difference of squares. So I could take the square root of a, and I can take the square root of c, and this is going to give me two almost identical binomials, just one's positive and one's negative. So the square root of 49x squared, we'll start with 49. The square root of 49 is 7, and the square root of x is, or square root of x squared is x, so it's 7x and 7x over there. And then the square root of 4 is 2 and 2. So it should be 7x plus 2 and 7x minus 2. And that's using a very special, very rare way that you can factor called the difference of squares. Will you use that every time? Absolutely not. You will use this maybe 1 out of every 100 times you're going to factor. But it's something special, unique, and something for you to see. Okay? So what I want you to do is now flip over, and I want you to try this mixed practice. Now on this backside, it's got this special difference of squares in there, all right? But it also has just binomials and trinomials that you can factor. What I want you to do when doing this is you need to remember, all right? Number 1, when it's set equal to 0, all right? When it's set equal to 0, you must use the zero product property and set each binomial equal to 0, all right? So for instance, on this first one, all right, on this first one here, when you factor it, all right, when you factor it, you're going to get this, m minus 4, m plus 4. Because what two numbers add to 16 or multiply to 16? but add to 8 or -8, 4 and -4. So now because it said equals 0, you set each binomial equal to 0, so this equal to 0, and this equal to 0, and you're going to get m equals 4. So anytime it's set equal to 0, you're actually going to solve and find me the x-intercepts. Also, make sure that if you can factor out a GCF, factor GCF, do that first. If your leading term is not 1, hey, look at that 19, you're going to want to factor out a GCF first and then factor. And if it has equals 0, means solve. Find me what exactly those x-intercepts are. If it doesn't have equals 0, you are just factoring into two binomials, getting it in factored form so that we could eventually find what the x-intercepts are. Okay? So pause it, and then you can check your answers here. All right, so here are your answers. All right. So these are the answers of your mixed review. All right. So if I went too fast, replay it. All right, pause it. And I'm going to go back here so you can see the top. All right, so hopefully, again, pause. Hopefully you got the same answers as me. If not, well, I suggest that you come in early on Tuesday or after school on Tuesday and we can work through this stuff. All right. Your homework tonight is a worksheet. So please, when you're finished with this and you feel good, go up to Mr. Nelson and grab that worksheet from him. All right. Again, all the answers are on the back, so make sure you're working and checking your answers. Okay. Please be good to the sub. All right. I'll be back on Tuesday to answer any and all questions that you have. All right. Have a great day, and I'll see you Tuesday.